without further ado, today we're going to go over the new reality of risk. So talk a little bit about why alert fatigue is exploding, why you're being overwhelmed, what is contributing to that. We'll talk a little bit about the AppSec bottleneck, so why detection is less effective, why we're shifting from what was the norm into our new era of AppSec and recommendations as to how you can do that within your own teams and own practices. And we'll show you a little bit of how you can do that in practicality and in reality with some of the tools that we have to offer, both free and paid. So stay tuned for that. Okay, I'm sure everybody on this call is very familiar with the fact that the reality of risk for everybody is changing. It's changing at a rate that we have never seen before. And a lot of that can be contributed to AI code generation, and being able to take processes that were once quite manageable that have now evolved into something that's a little bit harder to get your arms around and to be able to tackle from a security perspective. On top of that, in conjunction with this, there's also an explosion in the amount of dependencies, frameworks, and therefore the attack surfaces that you have to manage, which make the whole process seemingly impossible to manage from a security perspective. And we'll talk a little bit about why those processes are making it a little bit more challenging for you to be able to effectively impact your AppSec posture. This is not new news to anyone, hopefully, on this call, but we've all experienced that AI is dramatically increasing our velocity. So from a developer perspective, not only are developers increasing the amount of AI tools that they're using, so over 84% of developers, this is even from 2024, or from early 2025. So I'd imagine that this percentage has increased since we've even pulled these numbers, but they're planning to use AI tools, or they already are this year, and 51% of them use them daily. That being said, all of the impact of that is that software engineering can go a lot faster than it ever has before. I know a couple years ago, the whole phrase was like move fast and break things. I think if anything, this is being amplified now with a real lack of visibility and control from a security perspective, being able to get your arms around what's going on, even just to understand what types of AI components you have across your application attack surface. So these tasks are being able to be optimized. Essentially, you can move more efficiently. But because of that, that means that you're shipping code at a record scale. So you're being able to do more per developer, which means your entire code base is essentially exploding. And if you're relying on AI generated code, a lot of that contains security issues, both familiar and unfamiliar. And I'll hand it over to Daniel to talk a little bit about some stats that we found and our experience when we were building out our SaaS product and our AI generated remediation guidance and what we were seeing there.
So this graph comes from a study that was looking at whether the growth of the size of a large language model correlates with the correctness of a program it generates. And we were talking about a complete working backend application, and whether that also correlates with security. So whether the code bases that were generated were also secure, or were there some vulnerabilities. So what we see here is that on the right-hand side, we have the smallest model, and on the left-hand side, we have the largest model that was used for this study, and this was the largest model at the moment of conducting the study. And we can see that the correctness is growing steadily. So on the most right-hand side, only 5% of generated code was actually working. And on the most left-hand side, we have over 50% of generated programs were working. However, the percentage of percentage of generated code was also secure kept at the same rate. So around 50% of the programs were insecure. And so what this study updated me on was, or what it's suggesting is that we will not solve the security issues or the issues of AI introducing new security vulnerabilities just by scaling the models. So with larger models, we get more correct code, but we'll still get 50% of the applications which are insecure, which I think draws a conclusion that we need to do something extra. We need to do something else, not just rely on the development of the underlying technology.
Right. And I know that when we were working on our own internal products, we found that the code that was being sent back or delivered to these developers consistently tended to have not only vulnerabilities or weaknesses, but tends to have the same types of weaknesses, which was interesting because you would think, especially reflected in this graph here, you'd think that that would be able to adjust and learn on the fly and continue to like avoid those specific types of vulnerabilities. But we're finding that that isn't necessarily the case. So even when you think that something is going to be able to evolve and become better, it doesn't necessarily mean that you can blindly trust it and that it will be 100% better over time. We are just not seeing that yet. Maybe that will change, but that's yet to be seen. I'm sure we'll all figure that out as we're continuously scanning this new code that's being brought into our code bases.
One more quick thing that I will also add is that even if the large language models would generate code that is less insecure than human written code, still the sheer fact of how much more volume of the code we can produce with the same resources means that we'll be flooded with security issues.
Yeah, and we'll talk a little bit about that when we get down to some of the other slides as to like, okay, now what do we do with this, right? Like, how do we, as our teams are getting smaller and smaller and having to become more efficient with both our manual time, like people work hours, and our tools, how do we tackle that? How do we get ourselves to a place where we're not continuously treading water and feeling like we're drowning in a lot of these issues that continue to pop up? On that note as well, one of the things that is becoming a little bit more challenging, and I think you guys have seen this I'm sure you've seen this across your teams as well, is that the landscape of your application attack surface is changing dramatically. There used to be a very, I wouldn't say like predictable, but it was a lot more manageable to understand where you needed to focus your efforts on. Literally what you needed to scan, where you could imagine risks would propagate throughout your application attack surface. That is dramatically changing as we're introducing new technologies, multiple different types of dependencies and frameworks that maybe our teams aren't as familiar with. There isn't really it's getting better, but there isn't really a great easy path to understand which packages or frameworks that I'm using are aligned with my organization's security standards and guidelines, and getting even guardrails into that process is really challenging at the moment. So you'll see that over the last, honestly, maybe even 2 years, both AI and the implications of AI around exploding API attack surfaces has grown dramatically. And so those are areas that organizations typically haven't had strong coverage from a security standpoint. When you compare that area to SAST and SEA, those are very standard. Those have been around for a while. We've sort of gotten ourselves together to understand, okay, how do we secure our code? How do we secure our open source dependencies? AI is really shifting all of that around. And so it's rapidly expanding this attack surface while you're still trying to expand your coverage from a security tooling perspective. And while those tools are still trying to adapt to what that new risk landscape looks like and how to provide you coverage without assaulting you with a ton of notifications about various different potential risks. As you can imagine, this is not something that is easily manageable from both our traditional security processes, security tooling, and just human beings, right? We can only do so many things in a day, each of us as a person. So when a lot of teams are finding that their developer counts and engineering counts are being shrunk to be able to become more optimized, efficient, rely on some more tools to be able to help carry out tasks that maybe were repeatable and automated, or could be automated. But that means that as this scale of both risks and the potential of where risk can show up is growing, there becomes a real struggle and challenge for us to be able to actually do anything about these risks and the sprawl of your application attack surface. And that I'm sure we've all seen in the explosion of CVEs. Everyone is familiar with what happened with the NVD over the last year. If you're not, I don't know what to tell you. There's been a dramatic amount of influx of data, and they just can't handle managing and reviewing a lot of these CVEs, which puts us in a pretty difficult place because we're trying to understand, okay, what does this risk mean for me? Really, what is the impact of this on my application security posture? There's a ton of backlog on their end as well, which contributes to our inability to either detect or take action on things that are active risks sitting within our application attack surface. And that's also reflected in our ability to be able to identify and then contain or mitigate a lot of these risks as they come up. Those are direct reflections of the things that we touched on in these last couple of slides. So getting to this, before we jump into our points on the AppSec bottleneck, we have a poll. Feel free to participate in this. We're curious to see what is the biggest AppSec bottleneck for your team. And I know we have 2 polls today. I know there's not an option there for budget. That's always going to be an answer, and I understand that, but let's just pretend that we all accept that that is the reality, and we all agree that that is something that is holding us back. But while we fill out this questionnaire, what we're seeing from a lot of our customers and within the market is that this historical focus of AppSec and the tools that have been built within that market focused on, okay, let's make sure that we can find and detect every single risk that we can. We need to ensure that we have visibility across all of the things that are going on within our application attack surface. However, because we focused on that for so long, and now we're going into a space where everything is exploding, we've sort of created this problem for ourselves where we don't have enough manpower, we don't have enough ability to create a significant dent in our backlog and effectively reduce our risk overall. And because of that backlog just sort of sits. Sometimes they're low risks that sit there and maybe they aren't reachable. Maybe they're within an internal network that's less of a risk, but there are some that are sitting there that need to be addressed that you just can't for whatever reason. There's either it'll break the build, there's no direct path to mitigate it, you don't know what to do with it. There's a ton of different reasons why that can linger there. But it does create this massive backlog and bottleneck that your AppSec teams have to deal with. And on top of that, one of the things that we're seeing is that the mean time to remediation is growing. So for critical issues, used to be a lot more simple to understand the context and the impact of some of the risks that come along within your workflow. That is becoming more and more complex as we continue to create really great applications and evolve over time. A lot of these risks become really tied to context and a lot more complex than what we've seen previously, which makes fixing and being able to have a direct path to fix a little bit more challenging. We're starting to see that shift, and we'll go over that in the next couple of slides, but that's something to just keep in mind as well. Okay, so we are seeing, it looks like everybody has pretty much felt all the pains that we've gone through today. The top bottleneck that people are seeing is not enough developer capacity. That's something that we'll touch on when we're going through how can we make use of the tools that we have to help augment or extend our human ability to address some of these risks. The next are all pretty much tied or very close with too many alerts, lack of prioritization or context, and then tool integration challenges. So we'll talk a little bit about all of those today as well. Okay. All right. One of the things that I did want to talk about when we're talking more directly about the AppSec bottleneck, which we touched on a little bit, but I wanted to just zoom in on this a bit more. Um, Historically, AppSec focused on detection and finding. This, in today's day and age, has become a little bit less effective because what we're looking at has dramatically changed. Um, the scale of new code is something interesting to note because when SaaS tools were originally designed, they were built for a different development lifecycle, essentially. The points at which you would traditionally scan, how long those scans would be and how intense they would be, in terms of how many findings or how sensitive they were to pick up these findings, right, looked very different. Now we're coming to the point where we're trying to be able to address these risks as early as we can. So as code is written in the IDE. And it's interesting to note here as well that like this started a while back where we were introducing all these plugins into the IDE. A lot of security teams said, well, I don't really know how I feel about that because there's no real way to track that. There's no real great way to get governance within that area of the developer lifecycle and the developer environment. And that makes it challenging for me to be able to understand what's going on within my organization. So we moved collectively, we AppSec vendors in general moved to say, okay, you know what, let's do it on the pull request then. Let's start scanning at a different point in the life cycle, still early, but being able to make sure that you're getting an integration or a touch point where multiple teams are able to still have visibility and address risks in a way that's efficient and natural to their own workflow. But with the explosion of AI generated code and the way that this new world order of software development is happening, it's becoming more and more imperative to shift back again to being able to have a touch point in the IDE. So that's something to keep in mind. This detection is just looking a little bit different, right? We're trying to understand where are the best places to test. How do we ensure that what we're testing for can be adaptable and flexible to meet this new software development lifecycle, as opposed to how we've done it in the past. The other point I wanted to touch on was shadow AI and shadow IT in general, but shadow AI is a little bit more pervasive and a little bit more interesting because there aren't a ton of tools that are able to continuously monitor for shadow AI components well. You can do it to a certain degree, and we'll talk a little bit about like how you can help make sure that you have visibility into that. But if you're relying on a lot of your traditional tools, they weren't built to be able to detect these types of things, right? We're seeing a lot of vendors, us included, being able to now do this to a good degree where you have an understanding of what's going on within my application attack surface and how do I even start to address these risks, right? The other reason why detection has become a little bit less effective, and it's going to require a change in how we go about not only finding but addressing these issues, right? The more important part is that a lot of these AI risks, especially when you're talking about conversational AI, they're dynamic. They're behavioral risks that weren't the traditional type of risk that are the engines that we rely on historically were designed to detect. So that requires a little bit more creative thinking and tooling to be able to connect the dots between what's going on in runtime, where these risks evolve and continuously change as they interact, as AI interacts with your customers, prospects, what have you, to be able to connect those dots back into your code base so that you can then remediate them effectively. And I know that we talked a lot about, okay, what's going on? Why is this challenging? Reflecting back the current state of the world. But as I'm sure you guys have experienced, remediation has become a lot more urgent. We have building backlogs, we have developers that are swamped. But the other two or three major points that are changing is that the ability or the time that it takes for an exploit to be successfully, or a vulnerability to be successfully exploited, is shrinking. So while we are struggling to maintain our coverage and remediation efforts around risk, these risks are being exploited faster. That puts pressure on us to be able to say, okay, we need a way to remediate this faster, to understand and mitigate this as quick as we can. On top of that, as all of these things are happening, AI opens the door really for a potential amplification and sprawl of both the tools and the risks that are propagated across your code base, especially if you're using AI agents that can autonomously take action. That's something that you have to be mindful of and be able to have a path to visibility and to fix a lot of the issues that are coming up when those agents take action, and you need to make sure that nothing is happening that you don't know about. And additionally, of course, anytime we're moving into a new market where there's potential for serious harm, there comes a lot of new regulatory, so compliance liability pressure, making sure that you can prove that to the regulatory bodies that you interact with, as well as your stakeholders and customers. So not only being able to prove that you're doing something about these issues, but showing that you're doing so with good intention, with a timely manner, and aligning to all the new standards that are coming out over the last couple of years and will continue to in the coming months. So now we're taking this new approach. We, as the general AppSec, we trying to understand, okay, let's move from being able to detect everything, from being able to actually do something to impact our security posture. So the key question here is for us to understand and to be able to showcase how teams can reduce this backlog and risk exposure in a way that's efficient, effective, and takes into account all of the things that we spoke about in the slides before this. Okay. We touched a little bit on this, but it's just a reminder of the urgency, right? As these risks are being able to be exploited faster and we're getting slower, it really reemphasizes, okay, this is now the time where AppSec's having a little bit of a revolution. Instead of focusing on detection, we need to focus on how we can help people remediate. Without further ado, I will hand it over to Daniel. He'll take you through how we can tackle these risks, what we've seen our customers do effectively, and we'll give you a little bit of a visual peek into how to practically do this within MEN tools, as well as some best practices and suggestions for how you can take that to your team.
Okay, so Saoirse laid out the scope of the challenges that we can expect in the years ahead. But first, I also want to say that even if that productivity boost from AI never happens, if it never materializes, we have enough problems today to really focus on streamlining the remediation process and hopefully even preventing as much as we can before we need to remediate something. So I want to, as Saoirse said, shift the attention to solutions. So how, in general, we can approach these problems, and also how we at MEND think about solving some of these issues. And I want to talk about the processes or the ideas in a way that's organized through a life cycle of a security issue. So start with the most detailed concepts, and then go to more abstract and complex ones. So I will start with preventing introduction. Then I'll talk a little bit about what happens if we cannot prevent introduction of new security issues. So whether we can automatically or maybe semi-automatically remediate them, either with fully autonomously without any human interaction or with minimal human interaction. And then if we cannot automatically remediate something and we do have a backlog of security issues, how do we manage this precious resource of human attention, and how do we direct that attention to things that are truly critical, things that matter most? And then when we have that, now is the time to make the remediation happen through a collaboration of multiple teams. So how can we facilitate the collaboration between different teams to effectively remediate security issues. And then finally, I want to touch also a little bit about building security-focused culture, because I think it's not really a distinct step in the process. It's more like a meta construct, meta element of the process that makes either of the previous things work or not. Because if people truly care in our organization about security, then even if we don't have the best tools, we're going to have a good security. And if, on the other hand, we have the best tools, but people don't care about security, then it's just not going to work. So, Saoirse, if we could go to the first slide. Thank you. So first of all, how we can prevent introduction of new security issues. So first, let's start with the generative AI. Here we can start even before the code is being generated. So most of the AI native IDEs, such as Cursor, which is the most popular one, or Windsurf or GitHub Copilot, they offer a way to add rules, or they call it rules, but basically add a bunch of tokens before or after user prompt. So when user is asking the agent to generate some code, we can automatically append or prepend certain texts, such as, for example, never use hard-coded credentials or something like that. So it's not going to solve all of the security issues. We will still need other engines or other tools to tackle them, but it's going to help us a little bit. And then after the code is generated, then we have the second point at which we can act. So here at Ment, we've developed a MCP server, which the agent can talk with basically and ask, hey, I've generated this code. Do you think it's secure or not? And then we return an answer saying that, yes, it's secure, or no, here's why it's not secure and how you can fix it. And I'm going to show that in the demo at the end of the slide. And then we also have the process of just humans writing code. So here, Saoirse mentioned the IDE plugin. I think this is the next step in the cycle in which after writing the code, we can offer a solution in which in the environment in which developers work every day, we can have them showcase the security issues that are relevant for them. And I think this is the key part, that we don't want to show, that we want to show them just the most relevant issues and focus their attention only on those. So if we have, for example, a really large system, maybe with many languages, and a specific developer is only working on a part of it, we don't want to show them all of the other findings, because if we do that once, they will never come back to the tool, because that's just painful. And so that's the next step. We could even have an automatic pre-commit hook. So for example, if someone is committing the code, automatically we run the security check. And then the next step is the SCM, so GitHub, GitLab, Bitbucket, and so on. And here we can truly, we have more space and also more context to showcase the relevant issues that were introduced in a given peer, and also maybe show how we can remediate them automatically, which is also something that I'll present. And then finally, we have the CI/CD process, which is kind of like a final gateway, or rather gate, which we can set for preventing introduction of new security issues, or preventing the code that shouldn't be merged to the main. So, Saoirse, if I can take over the screen for a second. Okay. Okay. So I have a Cursor open, which is an AI native IDE. I have a very simple Node.js app here, and I have configured our MCP server. Maybe I'll, just to be sure, turn off and turn on, like the most important support fix. And here I have actually the rules for Cursor. So I want to ask it to, after generating any code, always run the security assistant that we provided. And I'm gonna use, I'm going to use a prompt that usually introduces server-side request for query, not always, but in most cases. And then, sorry. And then we're gonna see if how it interacts with the MCP server. And what I wanna say is that often it goes through multiple rounds. So it sends the generated code, it retrieves a response, and then it tries to fix it, but it does not fix it fully. So as you can see, it had some task list, and then at the end, we have the run SAST security analysis on the new code, and we can see that it's trying to call the MCP tool. Let's wait for the result. Okay, so it's calling demand security assistant. And in fact, it did found the server-side request forgery. There's some description, and there's also a suggestion on how to resolve this issue. So now it made the changes in the generated code, and it's calling the tool again to verify if that solves it or not. So we may go back to this in a second to see what happened. But meanwhile, I want to also show you the remediation in the pull request. So here I have the same exemplary app in the GitHub repository, and I have a pull request opened with a new endpoint that is introducing a new vulnerability. And we can see the summary of this vulnerability. So this is a path directory traversal, and we can see that there is a remediation suggestion. So if we scroll down to the code, it suggests how we can resolve this vulnerability. So basically to check if the path that the user provided is in the expected directory. And we have two options. We can either create a pull request to our branch, or we can update it directly. So let's say we'll update it directly. We need to wait for the change to be applied. And refresh. So now we have a second commit, which was introduced by Mant. So the update to the to remediate path traversal in index.ts. And here we have the same code change that we've seen. Okay, let's go back to the cursor and let's see what happened. So now it called the assistant. The assistant said that there are no more vulnerabilities. So perfect, the security analysis show no vulnerabilities. Now we're done. Okay, back to you, Saoirse. Yeah, so this was prevention of introduction of new security issues, but we can also automatically remediate. And here we have a couple of qualitative differences between supply chain and custom code. So with supply chain, we can really do a lot more automated remediation. So one of the tools that we use at Mant, or that we offer at Mant, is Renovate, which automatically or semi-automatically updates the packages that we're using in our code. So if there's a newer version, like the easiest way to prevent security vulnerabilities is to be on the newest versions. But then also, if we connect that with the SCA tools, we can have automated vulnerability detection and automated PR creation for the security issues that were found. And what's even more important is that we can again focus developers' attention on what's truly matter for them. So you can, for example, batch the PRs for specific language. So if we have a large project and we have multiple languages, we can batch all of the, let's say, Java libraries into one PR so that the developer who's working in Java part can review it and it does not bother other developers. And what's important here is that we can set it to automatically resolve certain issue, which I'll show in a second. And what basically it does is that it looks at the so-called merge confidence metric, which is basically how safely we can merge, how confident can we feel about merging this specific package update. And it takes into account things like age of a package. So is it at least a week old, about test passing, about adoption rates. So do people actually adopt this version and so on. So maybe I'll show that as well. Okay. So first, let's look at auto merging. So we have this renovate setting in which if we have a minor version or a patch version, we want to automatically merge it. And that indeed happened in this repository. So if we go to the closed PRs, we can see these labels, which indicate the merge confidence we have. And for example, we have this very high merge confidence. And if we scroll to see what happens, is that the PR was opened by the Renovate bot or by Mend. It added the confidence. But then it force pushed the commit, and then it merged the commit into the main. So it was fully autonomously done by the Renovate. It detected that there was a package updated. It created a pull request, and then it merged the pull request. And then what's really cool, I think, is that we can connect that with the SCA. So if we go to see security issues, we can see that there's a package that has transitive vulnerabilities, and that automatic remediation will be attempted for this issue. And then when we go to the pull request and we find that renovate package, we'll see that by merging this PR, we will resolve and close the following CVEs that we have in our source code. So I think this is a really powerful tool to really expedite remediation that comes from supply chain. For custom code, it's a little bit different. I presented the pull request user flow. So there, users usually want to have much more control over what goes into the code base. So we don't want to really do it automatically, but we can still present some potential solutions to the problems to the users to make it easier for them to remediate. Let's go back to the slides. Okay, so now we move to the next part. So we had preventing introduction of vulnerabilities. We want to automatically remediate what we can, or maybe semi-automatically do some other parts. Now we have a backlog of issues, and now we have to decide what truly matters most. And we have a couple of interesting new developments in this area. So here the main problem, the main bottleneck is focusing the attention of the human in the loop on the truly the most important findings, and we can do a couple of things to do so. So one thing is that we can correlate findings from multiple sources. So for example, we can have a SAST engine scanning our source code, but we can also have a Dust scanning our endpoints and looking for specific exploitation paths. And now, normally we would end up with just two lists, and then we would have to have a human who goes through one list and the second list and then tries to figure out what's going on. And we can help with that process. So we can automatically detect which issues are about the same issue, which findings are about the same issue, and show it in one coherent way so that we know that if we have a Dust finding for our SAST finding, it really most likely is a true positive. And what's more, there's an evidence that it can be exploited. So that's also something that I'm going to show. But before that, we can also flag the issue that are most likely to be true positives. So even if we have some findings that, for example, we have SQL injection, we have some user input, we can distinct whether that user input comes from the web, which is very dangerous, or if it comes from environment variables, which is still dangerous, but it's not as dangerous because someone has to have an access to our environment variables to be able to exploit it, which is much harder to do. So we can detect whether certain finding is of high probability to be used or not. And then finally, what is really exciting and interesting to me is that the question of whether we can use AI to solve or help solve some of the AI generated issues. So one of the ways that we're thinking about using AI is to truly understand the context, both business-wise and technology-wise, of specific finding. So for example, is the specific repository in which a finding was detected, is it a large open app which has an access to database with important customer information, or is it some small internal CLI tool that's maybe even never connected to the internet? If we have a like less severe finding in the first case, it may still be more critical to solve it, even if the finding in the second case has higher severity. We can also use AI to try to understand all the information, analyze it, and provide that analysis to the user for them to verify if it makes sense. So we can try to use AI to analyze all of these factors and present its conclusion for the use to help the user draw their conclusions. So maybe I will show the first point now, so about combining multiple sources. So this is our platform. I know that it can be a little bit overwhelming, but we have basically an intentionally vulnerable project. We have some findings from a SAST, and here we have risk factors. So something that we use to indicate how risky this finding is. And we have this exploitable risk factor. So let's open it. And in the details, we also see it. And now we have this row about evidence, which shows that we have one dynamic finding. So here we can see that this finding relates to API exec endpoint and that we have a command injection here. So let's see what happens when we go to the dynamic findings. And here we also have this command injection finding with a specific URL, which is also API exec, which shows how it can be exploited. So now we know that this finding that was found in the source code has also been found through dynamic testing of the API, which means that this finding is very likely to be true positive and it's very likely to be exploitable. Okay, let's go back to slides. So now we have, let's say we've prevented what we can, we automated what we can, we triaged and prioritized and used the cool AI technology to do so. Now we need to actually remediate the findings that we think are the most important to remediate. So now the problem is not really focusing attention on the right thing. Now we enter the coordination problem. So how do we make multiple teams, so developers, security team, but also product, DevOps, maybe even other stakeholders, how do we make them collaborate well so that the issue can be resolved effectively? So the first and the simplest thing is to integrate with collaborative tools. So to integrate in the work environment that the concrete people are using. So whether that's Jira or Slack, whether that's work management or communication, we want to have tight communication between the security tools and the workplace tools. The second thing is to have clear SLAs by severity and time, which sets clear expectations between the teams. So it's like serves like a contract between different teams. And I think this clarity is really, really important. But it's also important to notice where the friction point in collaboration exists. So for example, one of the most severe cases of that is the handoff of security issue between security team and the development team. So the developers want to move fast, they want to deliver, and for example, they may want to suppress certain finding as either acceptable risk, or maybe they think it's a false positive, but it's truly a responsibility of security team to judge whether that finding is acceptable or not. So we can have a workflow which deals with frustration of both sides. So developers can be frustrated with slowness that security introduces, and security might be frustrated with over suppressing of finding and not being careful enough. So here we can have a process in which the developer requests suppression so that the security person can feel kind of confident about what goes in and what does not go in. But also we want to nudge the security person so that if they're not responding fast enough, or if they're blocking developer, that they get some sort of notification or communication that, hey, someone is really waiting for this. And then my final point is that we want to have systems that are flexible. So every team has different way of working, and also the same team in different points of time has different way of working. So it evolves. And we want to have a tool that lets the team set policies and workflows in a new way, lets them change them in a way that it's not breaking things. So it's flexible. We don't want to have a really rigid system that kind of imposes certain workflow on the user, even if sometimes we want to have some elements of that. So for example, with the approvals process that I've described, what we do at Mend is that if your rejecting a suppression request, we require you to provide a comment. So you have to explain why it's rejecting, because otherwise it's just going to lead to frustration. Let's go to the next slide. And then the final thing, which kind of strengthens every point made before, is the culture. And maybe so I'm really interested in how that affects the process, because I think the culture kind of transcends and also is more important than specific methodologies or policies or templates and tools. I really believe that if people are truly motivated to care about security, then everything else will fall into the place. But I might be biased because of my psychology background. But if we want to analyze what kind of security-focused culture consists of, I would say that there are 4 elements of that. So one thing is that people and the organization needs to be motivated to care about security. And there are business and personal advantages to do so. So on the business side, if we don't have data bridges and our competitors do, then that's an obvious competitive advantage. But also even being perceived as an organization that truly cares about security, that's beneficial. And then on the personal side, for developers, for example, if we can provide them with the security process that helps them grow their skills, then that's going to be beneficial for them personally as well. So for example, if we provide them for specific training materials for the specific finding that they have introduced into the code base, that's going to be kind of addressing that issue. So the motivation is the main point, and the second point is kind of a philosophy or narrative. So an explicit discussion or explicit, maybe even document, or the form is irrelevant, but having an explicit thoughts about how we act when delivery speed and security collide. So like the main or the most common issue around security in building tech products. But also the second thing that I think is important is what kind of stories do we share? So for example, if we're onboarding a new developer, what kind of stories are shared to present to describe certain policies or why certain policies exist and so on, but also what people talk about in corridors, in unofficial meetings. And I think it's truly important to kind of think about and notice what kind of stories we tell to each other, because that's what builds the larger narrative of a given team. And then we go to habits and rituals. So having a specific ceremonies or meetings around preventing security issues, but also what happens if we do have security problems. Can we do it in a blameless way? But also what we learned and so on. So really kind of following the rule that what we do is who we are. So like having repeated in time actions around security. And then finally, the last point, and I think it's consciously the last point, is the environment. So the tools, the templates, the defaults.
And just to reiterate that tools point, right? The tools that you rely on should be able to empower you to do all of the things that we talked about today. To recap some of the things that Daniel walked us through, they're all part of the Mend AppSec platform, but the particular parts that we went through were all wrapped into Mend SaaS, the platform from more of a workflows, policies, reporting, setting SLAs perspective, being able to correlate findings across different engines. That's definitely more of the platform itself, which is beneficial for you guys. We sell based on the platform. And then Mend Renovate as well, which does have both a free open source option and the ability to enhance that capacity and speed within Renovate is more of a paid option, or you get that as part of the platform anyways. So these are things that we touched on today. I just wanted to say thank you before we jump into our questions. We also do have a poll, so while I'm pulling up your guys' questions, we'll go ahead and launch a poll. Feel free to interact with that, and I can share the results of those as well. Let me just open up this Q&A. Okay. Oh, so there's a couple in here already. One of the first questions is, we've invested heavily in scanners, but we're starting to see more AI risks creep into production. How do we address this? So I think this is worded a little funny too, because I'm assuming they're talking more about like traditional scanners, so SAST, SEA. How do you address AI risks that are now alive in runtime, in production, in applications that are exposable to the public? I would say there are a couple different ways to address this, and we can do this. We do this on our side with Mend. The first would be to be able to have early on detection of both in an inventory continuously of your AI components. So think about AI models, frameworks, both that are present within your code and interacting or called by your code. Um, Within our platform, we can do that in a couple different ways. It's included in Mend AI, but the ability there is to be able to early on detect one, what do you have, what risks are tied to those, and what are the paths to fix for that. So that's a way to catch it earlier on in production, or earlier on before it reaches production. Once you get into runtime and production, particularly if you're using conversational AI, we offer another way to red team those AI models and general conversational AI that you're using within your organization to be able to test how it behaves in real time. So that will catch issues that are not just vulnerabilities, but more weakness based. A lot of these tend to be aligned with both security and quality. So that's definitely a path that you can take there. But generally, I think the way to tackle being able to prevent them from getting into production early is to rely on tools that are able to not only detect what you have from an AI perspective, but tie those risks or tie those components to risk directly and be able to show you like this is the best path to fix and this is how you should continue to mitigate that in the future, whether that's like creating policies that you can or developer guardrails that you can implement within your organization. The next question was, what's works best MTTR wise for embedding remediation into dev workflows? So what we've seen from our customer base historically, and this is in part because of the rapid evolution of things, I'm sure this will continue to grow, but also might change as we're able to detect more things on the AI side. But we've seen our customers have incredible success with Mend Renovate. That's what we talked about in terms of being able to automatically update outdated dependencies. This is something that Mend historically has done well for a very long time. So our ability to take in, and because it is open source, it means that we have a ton of data to work with to be able to give you a confidence score that really reflects whether or not this change can be trusted, the confidence level there, and then will this break the build for me or not? So when you're able to knock out issues that are low risk, won't break your build, and take up or help you knock out a significant amount of your backlog, this tends to positively influence the team's ability to remediate issues across the organization. So that's something that we've seen. It's also very easy. It's an easy entry point to be able to get started. So that tends to be why we see so much success there as well, just because it's also really easy to get started. You can continue to grow within Renovate as your organization scales really easily as well. So this is something that we've seen our customers do really well. Okay. Culture is hard to quantify. How can an organization tell whether they really have a security first culture versus security tools in place versus just security tools in place?
Okay.
Daniel, I will hand it to you to take over that question.
Yeah. So I think the clearest indication is behaviors. So whether we can observe that people are truly, for example, if developers are unprompted talking about security issues or raising security issues, that's a very healthy signal that people truly care about security. Another thing is what gets celebrated. So for example, as I've said, what kind of stories are being told, but also what people notice. Like, do people say good job if you find something, some security issue? Basically, what kind of behaviors are being rewarded socially and what kind of behaviors are not being rewarded socially. I would look at that. But I agree with the premise of the question that it's very hard to quantify. It's very hard to know whether in which place we're at. And I think in the end, it's kind of an intuitive call, judgment call.
One of the things we also didn't touch on either a little bit that we can call out just quickly is um, around being able to provide access to what I like to call like just in time or like contextual education for developers, right? Like it's harder to take on learnings or like courses, so to speak, if you're if you're trying to do your regular job and you're also trying to learn at the same time. The best, most efficient way to be able and effective to be able to do that is to learn as you're going. So one of the things that we do that other vendors do as well, but I would say Secure Code Warrior does a really great job. We partner with Secure Code Warrior and integrate with them so that if you get an issue, every time you get an issue, you have a link to a Secure Code Warrior course that's tied to that particular CWE or CVE, so that you're able to understand and contextualize yourself. Like, okay, with hands-on training of like, what does this look and feel like in code? Why is that a problem? How can I address this, and how can I prevent that in the future? And those are all pretty quick too, which is nice. It's not like you have to go through some very laborious set of videos for context there. But that's another way that you can like tangibly see and track one engagement, your developers' engagement in security and how that is progressing over time. But that's just one measurable tactic, I suppose, to roll up into whether or not you're impacting your security culture. Okay, I think we have time for one more. Um, isn't there a risk of relying too much on AI for triage and remediation, especially where explainability is limited? Daniel, I'll give that to you as
Uh,
well.
yeah, so I would say this is a good point. So absolutely, there is a risk. I think it's important to clearly mark when something is produced by AI so that it's presented in the proper context. So that's one thing. And then at Mend, or at least at SAST, we're right now leaning more towards seeing AI as an assistance rather than a replacement tool. So the final call is always on the human who's responsible for that. And then the AI produced tokens are just there to be helpful, but not to override or to replace human decisions, because there is a risk.
Awesome. Okay, final point. I will reflect the results of your poll. And it looks like most people, if they could change one thing about their AppSec program, other than budget, of course, it would be to automate more of the remediation workflow, then to improve developer experience, and then collaboration, and then strengthen AI and modern code coverage. So shockingly, no, not that many people filled in reduce alert fatigue, but I think all of those things will help contribute to that as well. All right. Well, thank you guys for joining. Like I said before, this session is recorded, so you guys will get the replay of this session. If you have any further questions that we didn't have time to address, please feel free to reach out to us. We're happy to share what knowledge we have, and hopefully help answer any burning questions, lingering questions that you guys have from today's session.